Good morning, ma'am. Today, I, Shraddha Agarwal, and my friends Sanaya Agarwal and Sirin Dolkar are going to talk about the types of EV vehicles. EV vehicles are playing an essential role in transition to cleaner transportation, reducing greenhouse gas emission, and improving air quality worldwide. As technology advances, various types of EVs have emerged, each catering to different driving needs and preferences. This presentation explores different types of electric vehicles, including the design, functionality, and the advantages they offer. Now, I'm going to talk about internal combustion engine. These vehicles are defined as those powered by engines that combust fuels such as gasoline or diesel to generate mechanical power. This technology has evolved significantly over the past century, making internal combustion engines vehicles a cornerstone to innovate the industry. As we proceed, we have talked about the key characteristics and advantages and disadvantages of internal combustion engines. Now we'll move on to battery electrical vehicles. These are a type of vehicles that operates solely on electricity stored in batteries. These vehicles eliminate the need for traditional fuels, relying instead on electrical motors for propulsion, making them a key component in the transition towards sustainable transportation. As we proceed, we have just showed the key characteristics, advantages, and disadvantages of this also in the slide. As we move ahead, you can see that we have displayed the future trends regarding internal combustion engines and battery electrical vehicles. There is comparative analysis of internal combustion engines and battery electrical vehicles. Moving on, we have future trends and innovations regarding internal combustion engines and battery electrical vehicles, but we'll talk about those hybrid vehicles which are a transition to EVs. Hybrid vehicles combine an internal engine with an electric motor, offering fuel efficiency and reduced emissions compared to traditional internal combustion engines. This serves as a practical transition towards full electrification by familiarizing consumers with electric components and reducing dependency on fossil fuels. Plug-in hybrids, which can operate as battery electrical vehicles for short distance, future bridge the gap between conventional and fully electrical vehicles, making them a viable choice for those hesitant about fully transitioning to EV. Thank you.
Hello everybody, my name is Siring Dolkar and today I'll be talking about the electric vehicle which uses flywheels and electric vehicle which uses supercapacitor. Talking about the electric vehicle which uses flywheels, it is a device that stores energy in the form of rotational kinetic energy. It stores energy when the rotor rotates and the energy is stored in rotational motion. Coming on to our next slide, we have advantages and limitations of electric vehicle flywheels. And if we talk about the advantages, first we have high power density, which means they can store large amount of charge in relatively smaller space. Second, we have rapid charging and discharging, which makes them ideal for use in high performance EVs, which require quick acceleration and disacceleration. Next, we have long lifespan. Unlike traditional battery-based energy storage systems, electric vehicle flywheel have long lifespan and minimum maintenance. Next, we have environmental friendly. Electric vehicle flywheel does not contain any hazardous chemical or material. And lastly, we have regenerative braking. Electric vehicle flywheel can be used in conjunction with regenerative braking system, which captures energy that would otherwise be waste during braking and stored in the flywheels. Going on to the limitations of electric vehicle flywheels. Electric vehicle flywheels are currently more expensive than traditional battery-based energy storage system. While electric vehicle flywheels have high power density, they have lower energy density than traditional batteries. Size of the electric vehicle flywheels can be bulky and heavy sometimes, which limit their use in certain electric vehicles. An electric vehicle flywheel spin at high speed and must be properly contained and controlled to avoid accidents. For our next slide, we have electric vehicles which uses supercapacitor. They stores electrical energy as an electrostatic charge in a double layer formed at the interference between electrode and electrolyte. Supercapacitor stores energy through a physical process which allow them to charge and discharge more quickly than batteries. For the next slide, we have advantages and limitations of supercapacitor. Talking about the advantages, first we have fast charging. Supercapacitor can be charged and discharged more quickly than batteries. Secondly, we have longer lifespan. Supercapacitor have longer lifespan than batteries as they can be charged and discharged without degrading. Third, we have more efficient energy transfer. Supercapacitor are more efficient at transferring energy than batteries. Coming up to the challenges of supercapacitor, first we have low energy density. Supercapacitor currently have a lower energy density than batteries. Secondly, we have high cost. Supercapacitor are currently more expensive than batteries. And lastly, we have limited range. Electric vehicles equipped with supercapacitor may have a limited range compared to those equipped with batteries. Thank you.
Now, I will be talking about solar power e-vehicles. As the world shifts towards more sustainable transportation system, solar power e-vehicles provides an innovative way to drive clean and green. Harnessing the power of the sun to reduce the carbon footprints, it is a zero emission transportation system. Now, talking about how does a solar power e-vehicles works. Usually in a solar power e-vehicle, solar panels are installed either on the windows, hoods or the roof of the vehicle, where the sunlight falls on the panels and get converted into electricity. This electricity can be used to charge the vehicle battery or can be used as supplementary charging. Now, talking about the future of the solar power vehicles, this is an important technology, and in the future it will play an important role of transportation. It involves efficiency of the battery lives, moving seamlessly with smart grids, etc. Moving forward, let us talk about the future of electric vehicles. Prediction says that by 2030, electric vehicles will take over 30 to 50% of the global vehicle sales. The role of electric vehicles is very important as it is a zero emission sustainable technology system. The role of electric vehicles in smart cities will play an important role, and government will have to pass policies such that the system of the electric vehicles and charging ports are such that it is easily be accessible and affordable. Concluding this presentation, I would like to say that electric vehicles are reshaping the automotive industry with cleaner, sustainable options. As technology and infrastructure will evolve, different types of electric vehicles will play key roles in reducing carbon footprints, making driving sustainable for future. Thank you.